Wow, that's loud. Morning, everyone. So very intimate crowd, I would suspect, on a Friday morning after a long event in Vegas. I was probably what I expected for turnout. The good news is we are going to do an iPad giveaway. So your chances just got like exponentially better. So we're going to do an iPad Air. The only thing is we were going to do business cards and give it away at the end of the session, but some people didn't have business cards, so we'll do the auto drawing afterwards, and then we'll mail it out and notify you guys who won it. So let me see if there's a few more. Okay, so this session today is really about network ready or a hybrid IT environment. So what we want to talk about is just some of the sort of the lessons learned as we're starting to move more toward this hybrid IT architecture environment. We'll talk about some of the trends that we're seeing. We'll talk about enabling flexible network architecture, and we'll kind of speak through kind of what stuff that we're doing to help kind of enable that and lower some of those barriers of entry. We're going to talk about sort of the next evolution around the AWS Direct Connect, so some of you may be using that today. So we'll kind of talk about what the next step of that is and some of the stuff that we've done there. We'll run through a couple of use cases, and there's a case study in there we'll kind of quickly review. And we'll talk about some of the challenges that we're seeing around going global as well. And then we'll do time for Q&A at the end. So certainly from a hybrid, I'm going to kind of, just for the sake of this discussion, I'm going to kind of blend public cloud and hybrid IT all together in the same discussion. But we're certainly seeing a lot of interest and starting to see adoption around private cloud and certainly around hybrid IT. I think we're still sort of at the early stages of that, but we're certainly seeing a lot of interest, and those discussions need to be more and more frequent right now. And some of the lessons that we're kind of, I guess, learning from that, first off, and is a lot of these, working with a lot of our enterprises that are starting to architect these type of infrastructures, are that sort of the old adage for real estate, right? Like location, location, location. So location really matters when you start looking at where you're going to place those cloud nodes. And the ability to get into an environment that has direct access to the rest of your ecosystem, right? And that might be the CSPs, NSPs, could be part of your digital supply chain, could be CDNs, whatever it might be, but be able to get direct access to that, and the ability to get highly interconnected in close proximity to that entire ecosystem. And that's where we're starting to see sort of the drivers and demand for some type of integrated, highly flexible, switched fabric environment that can kind of enable that high density of interconnections and the flexibility that we can build upon to start really enhancing the value out of that. And we're going to talk a lot more specifically around that switching fabric. So I think if you look, quantitatively, I think it's certainly evident that the impact of cloud computing is having on data center traffic, right? So if you look at in today's world, the vast majority of internet traffic either originates or terminates in a data center. So some examples, you look at, arguably Netflix and YouTube combined is 50% of the traffic during high usage, all originating out of data centers. If you're sitting, I sit in my office in Denver, and I'm going to my IT resources or going to my data center in Silicon Valley. If I'm going to the internet, that's proxying through my gateway in our data center in Denver. So a lot of the traffic is either all originating or terminating in a data center. And then when you look at what's actually happening, so in that scenario where I'm sitting in my office in Denver and I'm going to some other social media site, let's say, I'm proxying through my data center into probably another data center, which in the back end of that, everything that's going on in the back end of that data center to serve that content back to me, it might be reaching into ad exchange, pulling out advertising. It could be reaching into an analytics engine, all this kind of back end transaction that has to happen to serve that simple request back to me. It really starts to represent how much data we see. So you can see some of the stuff, I think this was Cisco's report, who's saying 2/3 of all future workloads will be put into the cloud. And they also go on to say that 4 times the amount of traffic is exchanged within the data center than outside the data center. So as you can see, it's really kind of drastically changing, first of all, the importance and relevance of the data center to these new architectures, as well as the ability to be in a facility that's highly interconnected and has the ability to move at high throughput and low latency these workloads in and out of these cloud environments. and this isn't to pick on anybody, it just is a recent, activity in the market. But one of the things, with Nirvanix, I think really highlighted some of the challenges around this. So with Nirvanix going bankrupt a few months ago, it stranded a lot of customers. And unfortunately, these customers were given about 2 weeks notice, I think, to move data out. So we were, helping them do a lot of those migrations. One of the customers in particular had 42 petabytes of traffic sitting in Nirvanix environment. So, and without a backup. So if you were to move that over their traditional internet services, I mean, what's that going to take? Weeks? More than multiple weeks? Let alone the ability to actually go out and on the business side of it and negotiate contracts, find out where they're going to move it to, all that stuff. So there just wasn't time. So we were able to help them through high-speed interconnects within the facility to migrate that data off just in a matter of 2 days. So it just kind of, I think, really highlights the value of being in facilities where you can be very flexible and dynamic, and when you can kind of accommodate for catastrophic events like this, and be very agile and move your environment as needed. Some of the challenges I think that we're starting to see now, and certainly are resonating around, a lot of the cloud infrastructures today have been architected around internet, right? And I think what we're trying to solve for now is how do we remove the internet as that sort of bottleneck or that barrier to entry? And I think as we look through sort of how this migration is happening, that's where the Direct Connect, we're going to talk about that a little bit more specifically, but the Direct Connect starts to solve for some of those challenges around internet or internet bypass, especially for the business-to-business side of things. It was interesting, I don't know if anybody got to sat through Werner's keynote yesterday. He did I liked the way that he summarized performance, right? He summarized it as basically performance equals I/O, right? Which I thought was pretty clean, pretty simple. And then he also went on to say that one of the key kind of measurements around performance is around consistency. And I don't know about anybody in here, but when I think of the internet, I certainly don't think of consistency, right? So as we look at trying to solve for these future kind of next-gen architecture, I'll call them, we need to figure out how to solve to get around the challenges around the internet today, how we can do this over higher speed, highly interconnected, private, secure connections. Yep. So I think what that's netting out to, and some of the challenges it's really exposing is we've got great advancements in software, great advancements in hardware, and what's kind of left still are some of the challenges around the network to be able to solve for this. So we've got to figure out a way to evolve the network to a state that it's as elastic and flexible as the cloud, right? So if you look at enterprise expectations, and we've all kind of lived with the internet and it's been acceptable, as we really start to adopt cloud services more, the expectation is that my network should be able to be seamless with my cloud. I should be able, today I can go to my cloud, I can order all my services, I can get my compute, my storage over a single portal, and I can manage, have visibility into all of that. And then the network is still completely separate, where I need to go out and figure out who I'm going to use for providers, or redundancies, and kind of architect that in the same way that I've traditionally done. So we need to evolve that to a way that the network is elastic, and we can manage that bandwidth to align with our applications. So how do we start to get there? I think one thing we can do is look at, I tell you, after 5 days in Vegas with the smoke and all the talking and air conditioning, wow. So one of the things we look at is kind of where we've evolved from. So traditionally, access to the cloud service provider has always been through internet, and primarily that's still the case today, right? Couple of maybe a little over 2 years ago now, we kind of pioneered this idea of private access, and we worked with launching with the first locations with Amazon for their Direct Connect service, which is the ability to take direct access from a customer's infrastructure within Equinix directly to AWS and access their services there. So it's private, it's high bandwidth, it's secure, and it really allowed you to kind of start bypassing internet and enabling use cases that you weren't able to do over traditional internet. And now where it's going, you guys might have seen this. About 2 weeks ago, I guess it was now, AWS announced the kind of the next evolution of their service, which is the ability to do sub 1G increments on your Direct Connect. So it's getting closer to the ability to kind of align your network requirements with what your sort of application and your usage is. So it's a good stack. It's still a little static, but it does give you the ability to at least start to look at what your sustained usage might be or what your bandwidth requirements are, and then get the economic model to start to align to that. So we looked at that. Certainly, I think it was great for us. Certainly in support of that, we really thought through, from our customers' perspective, and how do we start evolving this to that next level or next generation of network within the data center. So in support of that, we actually did things a little bit different. We introduced our internet, or our Ethernet exchange, which is our switching fabric. And the idea is we can leverage the switching fabric to aggregate our customers out of the data center, and now we can provide them with much more flexible environment, right? So they can get a single port into our switching fabric, and they can do virtual connections into AWS. Maybe you're doing, maybe you got a VPC and you're going to public, so you want to do multiple VLAN. You can start to segment that, and we also fully supported all the sub-rate increments. So you can do this now, and you can align your VLANs in the same increments of the 50, 100, 200, 300, 400, and 500 meg increments that AWS offers. And the other thing we looked at was, which is great, because I think, again, it starts to help you kind of get your bandwidth in alignment with your applications. But we gave you the ability to burst. So let's take an example of, say, a customer that average sustained usage is 300 meg or less. So they subscribe to a 300 meg service for us. But say on Saturday nights when they're doing a backup, they have the ability to burst to twice that. So they can actually burst up to 600 meg and use it for free while they need it. So it really starts to, now we're getting that kind of flexibility in there where we're trying to get the economic model aligned more with the application and the business needs, but we're trying to accommodate for those kind of one-off burst aspects that we all know are typical of traffic patterns. So, and then the other kind of third aspect around the economic side of it is we actually took control of the AWS port and integrated that in and offered as a single price point that aligns with whatever your bandwidth increments are. And the idea here is that this really sets the foundation for how we're going to start to evolve this data center network infrastructure. So as you look at, and kind of, looking now at a broader context around this, what gets really interesting is, look at that ecosystem that you have there now, and now envision that switching fabric that's in the middle of all of that starts to integrate seamlessly all those different elements around the ecosystem. So you can be very dynamic, very fluid, and agile across who you're moving. You can do best of breed carriers, best of breed service providers, and you can access them all over a single infrastructure. So I can get my physical connectivity into that switch, and then I can use it for logical connectivity to whoever I might need to go to. So it becomes very flexible and dynamic, and I think it's a good step forward in where we need to be evolving this. I want to walk through just a couple of use cases. By the way, we're going to have plenty of time for Q&A, so if you guys are ready. I want to walk through a couple of just kind of use cases around what the switching fabric can do. And this actually, I would change this graphic a little bit, because one of the things that's not shown on here is that switching fabric. So that's an existing global switching fabric that we have today, and it also has a high density of carriers that are on it today. So and this is an older number, but it's somewhere in the range of 7+ million lit buildings are attached to that switching fabric today. So if you add another element into this, not only do you have multiple cloud service providers that are attached to it, you've got multiple network service providers that are attached to it. And then as this evolves, you're going to start to have the rest of maybe your partners and other enterprises that are all attaching to it. So we're getting to this kind of seamless unified fabric that's connecting all these different elements together. Very flexible, and it gives us the ability to start evolving the technology and evolving the automation on that, where we can get to things like automated provisioning, automated deprovisioning. We can get to bandwidth management. So as an example, if I want to dynamically jump onto our portal and I can manage the bandwidth, so if I'm taking 100 meg now and I want to bump it to 300 meg, it gives us the ability to evolve this to a point where we can start to get take over control as an end user back of my bandwidth and start aligning that with whatever my cloud consumption model is. The first use case is really what we call Cloud Performance Hub, but think of this really as kind of a multi-cloud environment, right? So it's the ability for you as a cloud consumer, my end users to be able to come through and access multi-cloud environments over a single fabric. So I can start to, again, manage multiple, cloud services over a single infrastructure that's all logical connectivity. And I think we look at some big stats or something around, for every customer that's doing multi-cloud, they're doing 5+ cloud providers. And granted, majority of that's probably SaaS today. But this starts to get to that environment where I can really get better control over my network infrastructure. I can start to manage the bandwidth requirements. I can quickly move across these different providers, and you can layer in there the ability to also hit network service providers as well. So it starts to become very dynamic and very valuable as you're architecting these new infrastructures. This one is really it's called cloud-to-cloud transfer, but this is really around leveraging that single high bandwidth, high throughput infrastructure to start moving workloads. And it can be a magnitude of things, but one example might be you're doing backup or recovery, right? So you're doing, let's say, a DR solution. It gives me the ability to start to do that over seamless high bandwidth, 1 gig, 10 gig type infrastructure, so I can quickly move these. It's much more cost effective. Certainly for performance, I'm going to get the consistency that I'm looking for, the high throughput, and it's secure and it's private. So it really starts to create, again, a really high value out of the switching fabric. And some of the things we looked at, and there's actually I think a test case in here we just ran in our lab a few weeks ago. But if you're moving only like a 50 gig VM, it was 3 hours faster by moving it over a Direct Connect than moving it through our internet connection. So it's pretty interesting. And there's a slide later, I think we're going to talk a little bit about that. And this one really is getting more into kind of the hybrid IT models, right? And this could be, so a private cloud sitting there as an example where now you're leveraging this close kind of almost land speed proximity from your environment to your cloud partner. And it could be multiple cloud partners as well. So it's starting to enable use cases that we just weren't able to do before because you're getting the high throughput, you're getting the consistency, and you're getting that single digit type low latency between your environment and the cloud provider. And you'll see there's a case study I'm going to talk through a little bit later that gives a good example of this. This is the test case we did. This was just out of our labs, right? So what we did is we ran a couple of tests from our SVC labs to an instance in Amazon, and we ran the exact same test. So we did an FTP download, and we just did a large data set copy and measured the time it took to move those files between across the internet and then across the Direct Connect. So I mean, we knew it was much better, but I was kind of astounded at how much better. So on the FTP, it was 85% faster moving across the Direct Connect, and for just a large data set that we moved over, 145% faster. So if you go back to that statistic of a 50 gig VM is 3 hours, and you scale that out to really the data sets that we're dealing with nowadays, I mean that's significant time savings. I mean that's a pretty amazing improvement in performance, especially as you start to implement much more robust DR solutions and moving workloads across these different environments. This is a case study one of our partners did, and it's sort of how they leverage Direct Connects to enable sort of a business solution that they offer around DR. And if you look in general around DR, right, there's a lot of challenges. I don't know if you guys have done it in the past, but it can be extremely expensive, extremely complex. I mean, trying to sync, and keep in sync your production and your DR environments can be kind of an operational nightmare. And there's the business aspect to it around just trying to prioritize your DR activities over others, right? It always seems to be one of those things that gets deprioritized until there's some like catastrophic event, and it's like an oh crap, we need to move that up to the top of the list. So what they did, they actually implemented a solution where they dropped their arrays in one of our facilities and took a Direct Connect from their array over to Amazon, which allowed them now to replicate their data from their remote office, store it on the array within our facility, And then over that high-speed, like kind of LAN proximity, they were able to actually keep the data within their own filer and then access their compute within Amazon. So it really starts to enable a lot of use cases, again, that over the internet, this just kind of would be very, very challenging. So the high throughput and the latency is very important for this case study. And then also it gives the ability to start to replicate that into multiple availability zones. So you could start to do a US East, US West as an example, or something like that. And if you look at, this is just sort of a map that shows where we are today with Direct Connects. So there's 6 locations where we actually have the AWS Direct Connect node sitting in our facilities. We actually did something really unique with this last release for London, which is the ability to provide the Direct Connect. It's sort of in the same solution we were talking about earlier with the flexible bandwidth, the low sub 1G, and the burstability back to the AWS infrastructure in Dublin. And this is something I think leveraging the switching fabric starts to enable a lot more expansion around how we can move this stuff to market a lot quicker. This is just a map, and if you kind of sync between the two of these, you can see this is where we're located, the Direct Connects today, and then not surprisingly, where we're seeing high kind of global cloud hubs evolving, right? And I'm not saying this is a result of the Direct Connect, but certainly I think what we're seeing here is these certain markets, which again, no surprise, where we saw really dense network peering has drawn in cloud service providers and in turn drawn in cloud consumers, right? So we're seeing these particular markets with extremely high growth around cloud. So as a lot of CIOs are starting to make decisions around where to place their infrastructure, these locations seem to be the smart move, right? Because it's giving you that close proximity to that overall ecosystem of dense set of carriers, dense set of CSPs, and your partner ecosystem or supply chain that you need to tie into, and it aligns with these switching fabrics that start to enable that connectivity between all those different elements. And this is just a view of kind of of our exchange environment today, right? So very very robust global footprint around the exchanges that we have in place. And as we look at how we can move to market and accommodate for enterprises' needs, this switching fabric is what's there. And the cool thing about it is, as we evolve the technology, so as we start to layer in automation on top of this, so we start to provide API integrations and the ability to do auto provisioning and bandwidth management, it's consistent across the whole platform. And one of the things that we've definitely got a lot of feedback from the CSP side, as well as the cloud consumer side, is globally consistent offering is critical. So if you look at it from a CSP's perspective, I don't want to have to do these private direct access in different manners across each region. So I need to be able to have my pricing model the same, my features and functionality the same, my operational support model is the same. So in order to do that globally is really important for them to be able to deploy this. And if you look at from the other side, the cloud consumer side, I certainly don't want to have different experiences depending on the regions that I'm in and have different features and capabilities. And then, by the way, I've got different operational support methods that I have to manage depending on what region I'm in as well. So having a globally consistent service offering is very important. So lastly, this is sort of a couple of case studies that are a couple of examples of how we've had customers leverage these Direct Connects in a global manner that's really helped them improve their business performance, right? So Box is a good example where they had started building out and they started scaling sort of a centralized infrastructure, and they moved to geographically distributed environment that got closer to the end users, and they were able to architect an infrastructure across our various metros around the world, which resulted in about 60% increase in the performance to the end user because they were able to geographically distribute those instances and get closer to where the end users were. And the other one, which is also very interesting, is Badgeville. So Badgeville, originally they're probably a few they are, but they're sort of a gamification company. So they go into like large enterprises and help them gamify their online applications and drive usage, et cetera. So they started out in the cloud, and they grew up and they scaled very quickly in the cloud. And they got to certain thresholds where all of a sudden they started running into both economic and then performance challenges, right? Where they needed to look at how they could increase performance. They didn't have the visibility and control that they needed for their very specific application. So what they were able to do was leverage the Direct Connect because they had that land speed proximity again and the high bandwidth. They were able to pull back some of the databases and then right-size the applications on the databases that they managed and then leverage that proximity for the production environment to the compute. So it gave them a lot more control, and they were able to actually, result in like 15% response time, improve response time for their end users on the application. And then there also was significant, 40% operational support savings because that's they were able to implement a use case that they would have never, again, been able to ever do over the internet. So they were able to pull those applications back. They were able to, it was originally being managed by a PaaS provider in the cloud, so they were able to kind of take control of that again, and a great success case there.